Have you heard of Joule, the generative AI copilot from SAP? Did you know that Joule can really help you to actually generate ABAP code? Stick around, I'll show you how. Now, Joule is a kind of virtual assistant that is going to act as your digital partner, so your programming partner in a way, to carry out different tasks that you would usually do. So you are the co-pilot and the main guy who's doing all the flying, and Joule is your co-pilot. So he's there to assist you while you code. Joule is available across many products in the SAP portfolio, and depending on the context and the scenario in which it is being used, Joule can help you in many different ways. For now, for a quick and easy start, you should visualize Joule to be a chat window, and within this chat window, you can talk to Joule using natural language. Now, natural language, this term is very important. Joule is powered by a large language model, and this means that it understands normal human language. So if you want to get Joule to do something, there are no fixed commands that you need to type in or no buttons to press. You simply have a human-like conversation with it. You interact with Joule by typing in your requests and queries. So you communicate with it by writing words. Although I think what would really be cool is if Joule had a voice enabled interface. And then instead of typing it out, we would just say what we want. We would just speak out and Joule would work for us, just like Jarvis. Anyways, the capabilities of Joule can be divided, broadly speaking, into the following categories. Navigational patterns. You can ask Joule to navigate to a particular application. For example, here I am logged into my S4HANA public cloud tenant and look for the sparkling diamond icon. This will trigger up the chat window within which you can talk to your assistant. Now, let's say I don't know which app is used to view the purchase orders. So I'll just go ahead and ask Joule. I'll say, show me purchase orders. It shows me a list of purchase orders within the chat window itself. And if you scroll down, it also gives me an option to navigate to the app. I'll ask Joule to take me there and it navigates me to the relevant application. So this is the navigational pattern or the navigational use case by which you can navigate to a particular app by asking Joule to do that for us. The next is the transactional pattern. We can ask Joule to carry out a particular transaction. So let's say I want to see a card on my home page. So in the public cloud, we have the so-called my home page, and I want to see a card here under Insights. So I'll say, can you create a card showing me the purchase orders? Joule will go ahead and create the card, and then it will ask me if I would like to add the card to my home page. I'll say yes, add it. We can now see that the card has been added here. So Joule carried out a particular transaction or a particular task for us. We just had to talk with it. The next is the informational pattern. You can ask Joule for general information. Let's say I ask Joule, can I create a purchase order with respect to a requisition? And then you can see Joule gives us the required information. It also points us to the source document. And in the source document, we can get further guidance on the topic. So this is the informational pattern in which you request Joule for some additional information. The next is the analytical pattern. Using Joule, you can create custom analysis based on various data sets. Unfortunately, I have not yet tried this out myself. However, the following screenshot from SAP is available in which you can see that a certain analysis has been built by asking Joule to do it for us. These are the four main ways in which we will be interacting with Joule. They are called as interaction patterns, or you can think of them as capabilities that Joule offers us. And these capabilities are offered across various products in the SAP portfolio. And our focus is going to be on the Joule for developers. Joule for developers can be further subdivided into Joule in build process automation, in the SAP build apps, in build code, and in ABAP cloud itself. Now, these are different capabilities across different products, as you can see. For now, we will be focusing on the ABAP cloud capabilities. The AI capabilities of Joule in ABAP cloud can be further categorized into the following. First is the AI chat assistance. Now, using the Joule chat window, we can ask any ABAP development related questions to Joule. And this chat window is integrated within Eclipse. So let's see this AI chat assistance in action. A quick word about my setup. I am running Eclipse with a version of 2025-03, and this Eclipse is connected to an S4 HANA public cloud tenant through an ABAP cloud project. So let's go to the menu option window, show view, other, and then search for Joule. This opens up the Joule view. Now this is your chat window within which you will chat with Joule. So let's start by asking something very simple. I'll ask it, how do I use the value operator to construct a new table with some fields? So Joule will process the language in your request and give you a response. As part of the response, you can see a brief description about the value command. You will have a step-by-step explanation as to what you exactly need to do. It tells you, for example, start by defining a type, and you also have the sample source code. Then you should declare the internal table and then how to use the value operator. By using the copy button, this source code can be copied into your clipboard. Now this is very useful if you want to eventually paste it into your actual code somewhere. So this is really well presented information. This is exactly what I needed when I framed my question to Joule. Now, as you can imagine, this really feels like there is a knowledgeable assistant sitting right next to you to guide you. And this is going to make the life of us developers quite easy. So there's no more hunting around for what the correct ABAP syntax is, no more searching on the internet or reading through lots and lots of boring documentation. We simply need to talk to Joule, right? So let's not leave it here. Let's ask it something else. I'll put a follow-up question. In the source code generated by Joule, we can see that the purchase order number field was declared as a character field of length 10. Let's change this. I'll ask Joule, in the above source code, replace the type for purchase order to EBELN, and let's see how Joule responds. Have it, the data type for the purchase order has been set correctly as per what we asked. And there is also a brief description of what Joule has just changed. This means that Joule is aware of what was talked about earlier and takes it into consideration. So this is just like a real conversation. I'm going to take this further. This time I'll ask Joule to adjust the naming convention. Now in our project, we do not use prefixes for object names. So there's no ty underscore or ly underscore. I'll just say in the above source code, remove the prefix ty from the name of the type ty underscore line. And as a response, we see that the source code is further adjusted. The prefix ty has been removed. And again, Joule briefly tells us what it has changed. Let's do one final test here. Let's see how Joule handles data retrieval in the AI chat assistance. I'll ask Joule, how can I retrieve a list of material numbers maintained for the plant 1000 that have not been marked for deletion? and let's review the response. Joule tells that to retrieve a list of materials for a specific plant and filter out those marked for deletion, we need to perform a data query on MARC and MARA. These are the correct tables, and we also have a step-by-step approach on how to do it. And right below, the thing that we want most, the actual source code. So this is how the AI chat assistant broadly works. It looks like a simple question answer format. You have a question about ABAP, you ask the question in the chat window, and it replies back to you. So this is quite useful. Now let's explore the next capability, which is the predictive code completion. Now, whenever you are in an object that supports predictive code completion, you'll have a button here in Eclipse in the toolbar, which is called as the toggle automatic triggering of code completion. So if you want this feature enabled, you'll have to switch it on first. I am in a class and it's empty at the moment. There's just one empty method. So let's start. Now the way to prompt Joule to suggest some code for you is to use the comment double quotes and then describe what you want. So I want to first create a local type that is going to store the purchase order header data. So I'll say create a type with the fields purchase order, purchasing organization, purchasing group, and supplier. I don't want prefixes, so I'll say do not use prefixes. You can immediately notice the ghost code predicted by Joule. I'll just press tab and the code then becomes active. Now this is Joule generating code for you based on the prompt that you have given it. Now notice how you don't need to mention the data elements. Joule finds it based on your field names. Now a thing to note here, Joule has suggested BKGRP as the element for the purchase group. Now this is not suitable for the cloud environment and hence it is pointing to an error. I'm going to replace this with EKGRP, which is relevant for the cloud environment. Now there may be some other way to get Joule to suggest only cloud-ready elements, which I am not aware of at the moment. So I'll prompt Joule to now create a sorted internal table based on this type. So I'll say create a sorted internal table based on the above type with the key purchase order. And we can see that the command for the internal table creation has been suggested by Joule. In a very similar fashion, let's go ahead and create a second type that is now going to store the purchase order item data. So I'll say create a type with the fields purchase order item, and material number. And we can see the type being generated. Notice that this time Joule has correctly predicted that my next step will be to declare an internal table based on this type that we just declared. So it suggests me this code as well. And this is correct. This would have, of course, been my next step. Also, it notices that I had earlier instructed Joule not to use prefixes. So this time also, it has not used any prefixes. So this brings us to an important point. Joule is context aware. That is, it is aware of the earlier code that has been generated and the earlier prompts that have been given to it, and it adjusts itself accordingly. So now let's see how Joule handles data retrieval. Let's retrieve the data into the purchase order internal table. For that, we will be using the prompt fill the internal table purchase orders with data from a CDS view in the API state released. We see Joule generating a select statement on a CDS view, and this view has the API state released and is suitable for cloud development. Now let's do a data retrieval based on another internal table. Let's say I want to retrieve all the items for the purchase orders in this table. So I'm going to say for the purchase orders in purchase underscore orders, get the items. Now we can see that Joule is suggesting to use a select statement within a loop. And this is of course not so optimal. Instead, what I'll do is in my prompt, I'll try to point Joule to the correct ABAP statement. And I'll mention by using the for all entries command. And let's see if Joule picks up the hint. So there, now we can see that Joule first suggests to check for initial entries, which is always a must when we use for all entries. And then the select statement is done based on the for all entries command. Now this is what we would also have done. Now this brings us to a very important early lesson. The prompt that you build is very important in influencing the way Joule will react. So always play around with the prompt, play around with the wordings in the prompt to see what works and to see that the results returned by Joule are as to your expectations. Now let's say I want to create a list of unique material numbers that are present in the purchase order item table. Now without Joule, I would usually copy this internal table into another table, and then I would do a delete adjacent duplicates comparing the material number field. So let's see if we can get Joule to do this. Let's say create an internal table of material numbers and fill this table with materials from the purchase order items, no duplicates, and I want to use the value operator. So we see that Joule has built a new internal table of type MATNR. It has moved all the materials from the PO item table into the material table by using the value operator, sorted the table, and deleted adjacent duplicates. This is correct. In the next case, we will try to read a single record from an internal table. Let's say I want to find out the purchasing organization for a certain purchase order number. Now, without Joule, we usually use a read statement, or as per the new syntax, we also have the value command. Now, let's see how Joule would do this. So I'll prompt find the purchasing organization for the order with the PO number, and we see the proposed code is using the read statement. I can of course ask Joule to use the value command instead, and we can see that Joule is using now the value operator. The inline declaration is done correctly, and in the table purchase orders we are looking for the record where the purchase order number is the one that we are looking for, and the value of the purchasing organization is assigned to the newly created variable. So this is fine. This is exactly what we wanted. Now let's see if we can get Joule to predict code for creating and filling up an internal table based on records in another internal table. I want to build an internal table containing the unique purchase orders in the first column, and in the second column, I want to have the count of the purchase order items for that particular purchase order respectively. So basically, just group all the records in the purchase order item table based on purchase order number and find out the count of items within each group. So I'll define a new type first. I'll use the prompt create a type with purchase order number and an item count field. We see Joule proposing to continue the practice of no prefixes. So this is good, this is consistent, and we can see the type has been created. We also see that Joule correctly predicts the creation of an internal table based on this type. Next, I'm going to use the prompt, create a list having purchase orders and the number of purchase order items. Now we can see the code generated by Joule. It is doing a loop on the purchase order table, and then for each purchase order, do a lookup in the purchase order item table based on the purchase order number, set up a counter field that is always initialized to 0, and it is updated by 1 for every record found. build the record and append it into the table item counts. And Joule correctly predicts that the table to be updated is item underscore counts, the table that it had just created some time back. So this is correct. This is exactly what we wanted. We can see that Joule has created the code in an efficient fashion. One thing to note, of course, this could have been achieved in many different ways. In fact, I have noticed that Joule proposes different codes at different points in time for the exact same prompt. Now, I'm not sure why that happens. So it's always a very good idea to check what Joule has proposed, and if necessary, adjust your prompt by providing Joule a certain hint to use a certain command. Now here we have a piece of code, a type declaration that was already generated by Joule based on my prompt sometime back. Often we will have the case where we want to change the code for something that was already generated, right? So you want to update a piece of code. I want to add in two more fields here, the plant and the storage location. So I'll update my prompt. I'll put in the plant and the storage location. So nothing seems to happen. What I'll do is I'll just delete the earlier piece of code and place my cursor at the end of the prompt. And now we see that the code is generated again. So again, this is something to note that if you want to update the code, you may have to first get rid of the old code first, then update your prompt, and that will then do the trick. Now let's see if we can mass update an internal table. So let's say for all entries in the purchase order item table, where the plant is 1000, I want to set the storage location to E01. So I will put in the prompt, update the storage location to E01 in the purchase order items for all records where the plant is 1000. Now we see Joule is using the modify statement to update the storage location in the purchase order items table with the where condition. Now notice here I have not used the exact field name. The exact field name is actually storage location without the space in between. I have, however, added a space in between when I was building the prompt. In fact, if I change it further, let's say I delete the code and instead of storage location, I type in storage space LOC or even simply ST space LOC, Joule is able to resolve it into the storage location. Now, this, as I said earlier, is a big advantage of generative AI. We can use natural language. We don't need the exact field name. We can use natural language and Joule would still be able to interpret it correctly. Now let's see if I can mass update the purchase order internal table, but this time without constants. In the purchase order table, we have the supplier number. And for all the supplier numbers, I want to add in leading zeros. So I'll use the prompt. Let's prompt Joule, add leading zeros to all the suppliers in purchase underscore orders. And Joule proposes a loop. And within the loop, the conversion routine is used to add the zeros. Now, a conversion routine is, however, not suitable for a cloud environment, as you can see here. So I'll simply extend the prompt and ask Joule not to use it. Now this time we see Joule is using the modify statement on all records in purchase orders table to modify to update the supplier field after converting it using the new code for alphanumeric conversion. Now this is important to note. Sometimes we may need to point Joule in the right direction to use the correct form of the syntax. Now the next use case that we are going to see, I want to get the supplier names for all the suppliers. So I'll add in a new field in the type for the PO header called as the supplier name. And I want to use this field to store the supplier name. So I'll say for all suppliers in purchase orders, get the supplier name from a CDS view in API state released. Now, I don't know the name of the view which stores it. it doesn't matter. Joule is intelligent enough to tell this to us. Let's see. And now we can see that Joule is proposing an initial check first and then correctly retrieving all the supplier names by doing a select on the CDS view with the for all entry syntax. Another aspect, in my prompt, I had only mentioned to get all the supplier names. So of course, Joule retrieves it, but Joule also notices that in the same purchase orders table, there is a field called supplier name, and it correctly predicts that the next step I'm going to do is set the supplier name in this table, and it already gives you the code for it. So Joule not only does code generation for the current prompt that you have supplied, it is also context aware, and it knows the current situation in your source code and is able to predict what your next step might be and what is the code needed for that. Now, of course, it's not always going to be right, just like any other AI model, but in this case, it was bang on. So this is how we can use the predictive code completion capability in ABAP Cloud. I personally found this whole topic of Joule code generation and code prediction to be very interesting. It is really path breaking, especially if you come from the old school world of ABAP development. In this video, we were mostly working with internal tables, and in the subsequent videos, we will explore the capability of predictive code completion in other areas also, such as CDS views, wrap objects, etc. We will also look at the other capabilities of code explanation and automated unit test generation for classes and CDS views. In the meantime, let's open up Eclipse and let's start talking to Joule.